Hello students, in this video I would like to discuss about approximation algorithm and bin packing problem. An algorithm which returns near optimal solution is called approximation algorithms. A feasible solution with value close to the value of an optimal solution is an approximate solution. Approximation algorithms are used when finding optimal solution is an NP hard problem. Approximate solutions are found out in polynomial time. So in the previous video, we studied about optimization problems where either we minimize the value or maximize the value. And majority of optimization problems comes under NP complete or NP hard problems. That means we can't solve those problems in polynomial time. So in such problems, we are using approximation algorithms to find the solutions in polynomial time. Approximation algorithms doesn't give optimal solution, but it will give almost near optimal solution. But the advantage is approximate solutions can be found out in polynomial time. So one of the examples for approximation problems is bin packing. In this slide, we are going to see what's the problem called bin packing. In this problem, we are given n objects that have to be placed in bins of equal capacity L. Object I requires Li units of bin capacity. The objective is to determine minimum number of bins needed to accommodate all n objects. One more condition is there. No object may be placed partially in one bin and partially in another. So here we have some objects and also here we have some bins and all the bins are of equal capacity. So we want to place these objects in the bins. The objective is to find the minimum number of bins to accommodate all these objects. So one more condition is there. We can't partition the objects. That means half can be placed in one bin, half of the same object can be placed in another bin. It is not possible. So n objects, we have to place it in some bins. The objective is to find the minimal number of bins. While we apply approximate algorithm, we have 4 possible simple solutions. First one is first fit, second one is best fit, third one is first fit decreasing, fourth one is best fit decreasing. So the first fit algorithm works like this. Index the bins 1, 2, 3. So we have a number of containers or number of bins. First we number those bins as 1, 2, 3, etc. All bins are initially filled to level 0. That means all bins are initially empty. Objects are considered for packing in the order 1, 2, 3, n. So objects are considered in the same order as it arrived. To pack object I, find the least index j such that bin j is filled to the level r, where r less than or equal to L minus Li. Pack I into bin j. Bin j is now filled to level r plus Li. So this is the formal procedure to apply first fit. Once we discuss the example, these formal steps will be more clear. So now I am moving to the example. So here is the example. Let L equal to 10. L means capacity of each bin is 10. So we have a number of bins and each of its capacity is 10 units. Here n equal to 6. That means we have to arrange 6 objects. The objects are given as Li, L2, L3, L4, L5, L6. That means L1 is the capacity of object 1, L2 is the capacity of object 2. Similarly, L6 is the capacity of object 6. So here the value of L1 is 5. The meaning is object 1 will occupy 5 units. Similarly, L2 will occupy 6 units. L3 will occupy 3 units. And similarly, L6 will occupy 4 units. So initially we will take the first bin and the bin will be empty. So first we consider L1 or object 1 whose capacity is 5. So we took a bin, its total capacity is 10. O1 is placed in the first bin. So 5 units are filled, 5 units are remaining. The capacity of next object is 6. So we can't place it in bin 1 because remaining capacity is only 5. So we are taking a new bin and in that we are placing O2, that is object with capacity 6. Similarly, next we consider 3. So first we look at bin 1 whether there is enough space to accommodate object 3. Yes, there is enough space to accommodate object 3. So object 3 is placed in the bin 1 itself. 2 more units are remaining in bin 1. Next we consider L4 whose capacity is 7. First we check whether object 4 can be placed in bin 1. We can't place it because only 2 units are remaining. Next we are checking whether it can be placed in bin 2. There we have only 4 units remaining. So definitely we need one more bin. So we take one more bin and inside that we are placing object 4. So in bin 3, 7 units are accommodated or filled. Next we consider L5, that is object 5. Capacity is also 5. So first we look whether we can place it in bin 1. Bin 1 only 2 units are remaining, so we can't do it. Next we look at bin 2. There only 4 units are remaining. There also we can place that object. Then we look at O4. There we have only 3 empty units. We can't place O5 there also. So definitely we need to introduce one more bin. So take one more bin and we will place O5 there. One more object is remaining whose capacity is 4. First we look at bin 1. Can we place O4 there? Only 2 units are remaining. Then we look at bin 2. Bin 2 we have exactly 4 units remaining. So we will place that object 4 in bin 2. So now all 6 different objects are placed in bins. And here we got total number of bins as 4. So when we apply first fit algorithm, total number of bins required to store these objects are 4. So I hope you understood first fit. Next we are moving to best fit. The initial condition on the bins and objects are same as first fit. When object I is being considered, find the least j such that bin j is filled to a level r, where r is less than or equal to L minus Li and as large as possible. Pack I into bin j. Bin j is now filled to level r plus Li. So this procedure will be clear when we see the example. So let's move to example. The same problem here, but we are using a different approach. So first we take an empty bin. First we consider object 1. So object 1 capacity is 5. So 5 units of bin 1 is completed. Next we consider object 2. The capacity is 6. We can't fill it in bin 1. So we are taking a new bin and we are placing object 2 in the second bin. Next we are considering object 3 whose capacity is 3. Here we are applying best fit. Object 3 can either be placed in bin 1 or bin 2 because enough remaining space is there in those bin 1 and bin 2. But we are choosing the best position. So we are putting object 3 in bin 2 because there we have remaining 4 units, but in bin 1 we have 5 units. So we are fitting that object in the best hole, that is in bin 2. So we are putting object 3 in bin 2. Next we are considering object 3 whose capacity is 7. We can't place it in bin 1 and bin 2. So we are taking a new bin and placing object 4 in that bin. Next we are considering object 5 whose capacity is 5. The first bin itself we have remaining 5 units. So we are placing object 5 in the first bin. Next considering the object 6 whose capacity is 4. We can't place it in bin 1, bin 2 or bin 3. So we are taking a new bin and placing that in the fourth bin. So here also we took 4 bins to place this object while we are following best fit approach. Next approach is first fit decreasing. Reorder the object so that Li greater than or equal to Li plus 1, where 1 less than or equal to I less than or equal to n. Now first fit to pack the objects. So it is nothing but we are reordering the objects in the decreasing order. So here also we have bins of capacity 10. 6 objects has to be considered. First I am arranging this object in the increasing order of capacity. L4 will come first. L2 will come second. L1, L5 will come at position 3rd and 4th. L6 will come at 5th position. L3 will come at 6th position. We just arrange these objects in the decreasing order. So first I am considering object with capacity 7, that is object 4. Take a new bin, place the object 4 in it. Next we are considering object 2 whose capacity is 6. So we can't place it in bin 1, so take a new bin and place object 2 in it. Next we are considering L1, its capacity is 5. We can't place it in bin 1 or bin 2. So I am taking a new bin and placing on in it. Next we are considering object 5 whose capacity is 5. We can't place it in bin 1 and bin 2, but in bin 3 5 units are remaining. So we are placing object 5 there. Next I am taking object 6 whose capacity is 4. We can't place it in bin 1. We are trying to place it in bin 2. There 4 units are remaining. So place O6 in the second bin. One more object is remaining whose capacity is 3. 3 units are remaining in the first bin itself. So we are placing object 3 in bin 1. So now we take only 3 bins to fill all these objects. So next one is best fit decreasing. Similarly here also we have to reorder the objects in decreasing order, and in that order we have to apply best fit approach. So in our earlier example, it executes as same as the first bit decreasing. So there also the number of bins needed is 3. Although first bit decreasing and best bit decreasing obtain optimal packing on this example, they do not in general obtain such packing. For the given example, it gives the optimal solution for first bit decreasing and best bit decreasing. That doesn't guarantee in some other example or in some other case it may give the optimal solution. So one thing is, approximate algorithms generally gives nearest optimal solution. Here we got optimal solution itself. So that's all I want to share in this video. Thank you.